So let's talk about biofuels. On the surface, the idea sounds like a total slam dunk. We grow plants, we turn them into fuel, and then we run our cars on something renewable. I mean, it seems like the perfect answer to our carbon problem. But is it really that simple? Let's dig in.
And that really is the million-dollar question, isn't it? You've probably seen the headlines yourself. One day, biofuels are the future of green energy. The next day, you read an article saying they're even dirtier than the fossil fuels they're supposed to replace. So, what's the real story? To figure this out, we're going to dive into a massive study done by the French government that really gets to the bottom of it.
Okay, so first things first, let's just appreciate the promise of biofuels. The core concept is incredibly appealing, and it's easy to see why it gets so many people excited.
Yeah, I mean, look at how elegant this idea is. A plant grows, and as it does, it literally breathes in carbon dioxide from the atmosphere. Then we come along, process that plant into a fuel like ethanol. We burn that fuel in our car, and sure, it releases CO2. But, and this is the key, it's the very same CO2 that the plant took out of the air in the first place. It feels like a perfect closed loop, right? No new carbon is being added. But, as you're about to see, this beautiful little picture leaves out some pretty important details.
So, what exactly is missing from that perfect loop? Well, to find out, we need a special kind of tool, one that lets us see the entire story, from the moment a seed goes into the ground to the moment the fuel is burned in your engine.
And that tool is called a life cycle analysis, or LCA for short. The best way to think about it is like a full-blown environmental audit. It's not just about what comes out of a car's tailpipe. No, it looks at the entire production chain, what the experts call the field-to-wheel journey. This is basically the magnifying glass we're going to use to uncover all the hidden costs.
And here are the 4 major stops on that field-to-wheel journey. Each and every one of these steps comes with its own environmental price tag. You need fossil fuels to run the tractors and make the fertilizers. You need a ton of energy to power the refineries that process the plants. You need even more fuel to transport the final product. And then finally, you've got the emissions from the car itself. A real life cycle analysis adds all of this up.
Okay, so let's put this tool to the test. Now, it's absolutely crucial to get this. Biofuel isn't just one thing. Fuel made from sugarcane in Brazil is a totally different beast than fuel made from wheat in France or from palm oil in Indonesia. So let's see how a few of them stack up against good old gasoline.
All right, so just looking at greenhouse gases, the results are actually pretty impressive. This table shows the total emissions. Compared to gasoline's 90.1 grams of CO2, look at that sugarcane ethanol, a massive reduction. Even ethanol from wheat and biodiesel from palm oil look like a huge improvement. Honestly, if this were the whole story, we could probably end the explainer right here and call it a day.
But of course, it's not the whole story, not even close. You know, climate change is a massive, massive problem. But it's not the only environmental problem. And solving one issue by just creating another one somewhere else, well, that's not progress. And this is where our life cycle analysis really starts to get interesting.
Let's look at a totally different environmental impact, eutrophication. It's a fancy word, but it basically means water pollution caused by fertilizer runoff from farms. And here, whoa, the story completely flips. Gasoline is actually pretty clean on this front, but sugarcane ethanol is over 5 times worse, and ethanol from wheat, it's over 30 times worse for water pollution. This just goes to show you, there are always trade-offs.
But hold on, there is one factor, one hidden cost that is so enormous that it can single-handedly wipe out any and all of the climate benefits of a biofuel. This is, without a doubt, the biggest twist in this entire story.
And it all comes down to this single question, land use change. Think about it. If you chop down a rainforest, which is a gigantic natural sponge for carbon, just to plant palm oil for biodiesel, you unleash a colossal amount of stored carbon into the atmosphere. That's called direct land use change. But there's an indirect effect too. If you take a field that used to grow wheat for food and you start growing wheat for fuel instead, well, people still need to eat, so that food has to be grown somewhere else, maybe on land that, you guessed it, used to be a forest.
And this chart, wow, this shows the absolutely devastating impact. Just look at this with me. Bar number 1 is gasoline, that's our baseline. Bar 2 is palm oil biodiesel, if you don't account for land use change. Looks like a winner, right? But then, look at bar 3. When you factor in the emissions from deforestation, the number just skyrockets. It's not just worse than gasoline, it's nearly twice as bad for the climate. This one single factor can turn a so-called solution into an even bigger problem.
Okay, deep breath. After all of that, where do we land on this? Are biofuels good or are they bad? Well, as is so often the case with these big, complex topics, the answer is it's complicated. But it's not hopelessly complicated. We can actually draw some very clear conclusions from all this.
So here's what you really need to take away. First, that simple, perfect carbon loop idea, it's a myth. It just ignores all the energy and emissions it takes to produce the fuel. Second, using a life cycle analysis is the only way to see the true full environmental price tag. Third, the devil is always in the details. What the fuel is made from and where it's grown matters immensely. And finally, and this is the big one, land use change is the elephant in the room. If a biofuel is causing deforestation, it is almost certainly not a solution for the climate.
So we end here. This whole analysis teaches us that maybe the debate can't be a simple thumbs up or thumbs down on biofuels as a category. The real question, the smarter question we all need to start asking is, which specific biofuels, grown in which specific ways, on which specific land, are actually worth the full environmental price we have to pay? And that's a question worth exploring. Thanks for joining me.